So we'll talk now about eclipses, and we do that because especially in this relation between our planet and our own single satellite, the moon, there is a special thing about it. There's a special relation. In fact, it is actually true that the moon is the largest satellite in proportion to its own planet that exists in the solar system. It has a quite fascinating one. It's not formed the same way as, say, the satellites of Jupiter or Saturn or many other gaseous planets in the solar system have been formed. But again, that would be the subject of discussion for another class, another day. So we're not going to do that now. What happens actually, just because our moon is so big, and it's actually, if you remember, right, so you're looking at the moon, right, and remember how we talked about how it subtends an angle of 1/2 of a degree. It so happens that the sun, so the sun is much further away and much larger, actually, right? So this is the sun and this is our moon. The moon is about 400 times smaller than the sun, but it's also about 400 times more nearby than the sun is, right? The sun is 400 times further away than the moon is. And so as a consequence, right, the angle that the sun subtends is also 1/2 of a degree. So basically, on our sky, both the sun and the moon look the same. They have the same angular size, right? And it's exactly because of this reason that we get to witness eclipses. If you were to live on another planet, you wouldn't be able to witness this kind of events. All right, so what happens? Like just anything that you might know of, the earth and the moon cast shadows. And so when either passes through the other's shadow, we're gonna end up having an eclipse. So let's talk about them. The first type we're going to talk about are going to be the lunar eclipses. They can occur only obviously at full moon, right? The phase of the moon that basically produces this kind of eclipse because the moon is kind of beyond the earth, right? This is where the moon is. Obviously this is the earth and the sun is here, right? So the sun sends its light and then the earth casts a shadow, also so that's called the umbra, and also a region that's called penumbra, which is an umbra but it's not dense or as powerful. All right, and so if the moon is in the umbra fully, you're gonna end up seeing a total lunar eclipse. Okay, which means ideally, or if you think of it, you wouldn't be able to actually see anything because its eclipse is nothing to illuminate it, and yet it shows up as a red moon. And that is because just when the sunlight disappears completely, then there will be light coming from Earth, which is much cooler than the light coming from the sun. And cooler means also red, as we will learn, I think, in chapter 5. We're going to talk about this. But yeah, this is why in a during a total lunar eclipse, you actually see that so-called bloody moon. There are also situations when the moon is only partially situated in the umbra, the total umbra, right? So that part will be basically chopped off, so you don't get to see it. Or it's also possible that the moon is just in the penumbra, and so you do get to see the moon, just not as shiny as you usually see it. All right. So I just wanted to, these are the stages for different possible tracks in these lunar eclipses. But I wanted to draw your attention to the fact that, for example, these things, right, they look like some sort of crescents, right? So these definitely not moon phases. Okay, they're basically the whole full moon. It's only one lunar phase. Okay, it's just part of it is chopped off by basically the Earth, which is just in front of the moon, and so it does not allow for the light from the sun to come through, and therefore let you see the whole full moon. All right, how about the solar eclipses? Well, it's not just one type. It could be a total solar eclipse, partial, or annular. That's something new. All right, so here are situations when these different things can occur. A very important thing to remember, obviously, because the moon is in between the sun and the earth. This is always going to happen when we have a new moon. All right, okay. So if the moon, it's going around in its orbit, right? So at some point it's not going to be completely aligned with the earth and the sun, and then you end up with a partial solar eclipse. If it's perfectly aligned for just that 1 minute or 1.5 minutes, then you end up with a total solar eclipse. And sometimes, because this orbit is not perfectly circular, then the moon could be a little closer to the earth, and so that is going to kind of look like this. So this is sun, and then the moon, instead of being here, is going to be a little bit closer, right? So it's going to allow a little bit of sunlight at its edges. That is going to form that ring of light, and therefore the annular solar eclipse. This is a very nice image from space of a patch of the earth where the total solar eclipse happens. You see how it gets dark? It seems like the night just breaks in for 1 minute. It's kind of cool. A few years ago, actually, in what was it, August 21st, I think, 2017, was an eclipse, total solar eclipse. That was visible in the United States. So hopefully you have experienced that, you have witnessed that. This is a beautiful image from 1999, a total solar eclipse that happened somewhere in Turkey. And you see the sky becomes so dark, you get to see Venus, which you only see during the night. Hey, the next one, you should keep your eye and ears peeled. All right, for, and actually maybe even plan on traveling to see, to experience it. That's on April 8th, 2024. So actually this is This is the totality path, that's what it's called. Okay, April 8th, right? I don't know what I said before. April 8th for sure. If not, you can always Google these things. Yeah. They're documented, they're all calculated, the exact location of that shadow of the moon on the surface of the earth. So on that day, kind of 4 years from now, it's going to go through some of these cities. You might be able, to plan on being there for that day and experience that, obviously with some safe solar glasses. Never look directly at the sun unless you know you have a safe solar filter to do that with. All right, so if a lunar eclipse occurs every time the moon is full, and a solar eclipse, it's definitely related to the situation in which the moon is new. Why is it that we don't have eclipses at every one of these phases of the moon? The answer to this question is given by the fact that moon's orbit around the earth is tilted by about 5 degrees relative to the plane, this one, the plane in which the earth orbits the sun. So this is the sun, this is the earth, and this is the moon that goes around the earth. So let's use this pond analogy. This is the surface of the water, that would be the ecliptic plane, the plane in which the earth moves around the sun. Okay, now the moon that goes around the earth is going to be on this orbit, right? And that is tilted, you see, so it's kind of like that. That's going to be 5 degrees or something like that again, right? 5 degrees. And so that full moon, and right, this is, for example, a full moon that is going to be, because of the inclination of this orbit, is going to be basically under the surface of the water. And this new moon is going to be above the surface of the water, and this is full moon, and it is under the surface. So what this says is basically, right, in both of these situations, not an alignment with earth and the sun. So of course, if it's not an alignment, it's not going to be anything to eclipse, anything to cast shadow on anything else, right? On the other hand, in these situations, so look at this, we have a full moon here that is actually at the node, okay? The nodes, these are the nodes, which are, that would be the line where these two orbits, the moon orbit, okay, and the Earth's orbit, they intersect one another. So that forms these nodes. And the same here, right? So that means you actually get to have all these three celestial bodies aligned with one another. So you end up with having here solar eclipse at new moon, another one here, and then you have the full moon, right? Sorry, here, erase that. And another one here. So you see how it's only going to happen about 2 times each year. All right, so hope that helped. You can always read about this a lot more in the textbook, and hey, go on and try your hand at the problems in the homework set.